Hello, it's Mrs. Trombley. It is time for a little extension of Lesson 2.2, which was all about slope, and we're going to talk specifically about parallel and perpendicular lines. So, starting off with parallel lines and slopes, and we've kind of already learned a little bit about this. Two different lines in the same plane, so coordinate plane, that will never intersect are parallel lines, so they will never ever cross. Non-vertical parallel lines have the same slope, meaning horizontal, and all vertical lines are also parallel. So if you see two horizontal graphs, it's just a straight line going horizontally, and another one, those are considered parallel. Two straight up lines, vertical lines, are also considered parallel. But they don't have to be horizontal or vertical. They could also look a little something like this. So I have three graphs here, 1, 2, 3. And it's going to be our job right now to figure out which lines are parallel. Now, if you look at these, it kind of looks like all of them are, but we have to justify that. So it says which two lines are parallel. It tells you only two of these are. And they ask you to prove your answer. So parallel lines have the same slope, right? So let's write that down. Parallel lines have the same slope. Alright, so we already learned how to calculate the slope from a graph, right? By using rise over run. So all we really need to do to figure out which two lines are parallel is find the slope of each line. So let's start with this first one, and you can either go from here to here or from here to here, it doesn't matter. But the change in y from this point to this point is 1, 2, 3, 4. And the change in x is 1. So the slope of this line is 1. I'm sorry, is 4. Just kidding. The slope of line 1 is 4. Now let's see what the slope of line 2 is. We're going from here to here. The rise, the change in y is 1, 2, 3, 4, 5. And the change in x is 1. So the slope of line 2 is 5. Those aren't the same. They look pretty similar, but they're not. Alright, last one. The change in y to get from here to here is 1, 2, 3, 4. And the change in x is 1. So lines 1 and 3 have the same exact slope. That makes them parallel. So 1 and 3, and since we had to prove our answer, we're going to say both have a slope of 4. Almost done. You didn't think I'd just make like a 3-minute video, right? You know I'm quite long-winded. I like to talk. I can't help it. Alright, so now perpendicular lines. Two lines in the same plane that intersect to form two right angles are perpendicular lines. So kind of like a big plus sign, picture it. But it doesn't have to be straight up. It could be moved to the side. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical lines are perpendicular to horizontal lines. So if you had a y equals equation and an x equals equation with just one number attached afterwards, those would automatically be perpendicular. So I look at it as perpendicular slopes are opposite reciprocal. So go ahead and say m equals opposite reciprocal. And how I figured that out is because the product of their slopes is -1. Now, you learned a while back that if you multiply reciprocals, you get 1, right? Like 2/3 times 3/2, 1. 4 times 1/4, 1, right? So that's how we get the product of 1. If I need a negative product, that means one number needs to be positive and one needs to be negative, because that's how, when you're dealing with signed numbers, we get a product that's negative. You have to have one of each. So you're looking for opposite reciprocal slopes, and then you'll know that they would form a right angle, that they're perpendicular. So again, I ask you, which lines are perpendicular? Okay, now in looking at this, it does kind of look like either one of these. Like that looks like it could be a right angle here, and so does that. So we need to figure out which one's which. So let's start with line 1. Let's find the slope of line 1. We can just use a change in y over the change in x. So from here to here, the change in y is 1, 2, 3, 4, 5, 6. and the change in x is 1. So this would have a slope of 6 over 1. Let's do line 2. 1, 2, 3, 4, 5 is the change in y, and 1 is the change in x. So for this line here, what we're looking for to have a perpendicular relationship with lines 1 and 3 would be the opposite reciprocal slope of this. So if these two were perpendicular, it would be negative 1/6. That needs to be the slope of this. If line 2 was perpendicular to 3, it would be negative 1/5. So opposite sign, reciprocal number. So let's take a look. I'm just going to go from this point to this point here. So the change in y, we have to go down 1. And the change in x, 1, 2, 3, 4, 5, 6. So the negative 1/6 and 6 over 1 are opposite reciprocals. That makes lines 1 and 3. Again, so 1 and 3, and it's because their slopes, are opposite reciprocals. I'm going to list them. Negative 1/6 and 6. That's it. Short and sweet little lesson today. See you tomorrow.